Good afternoon, students. Good afternoon, all of you. Are you able to hear my voice? PCV is visible. Any problem? PCV is visible. The slides. Yeah, thank you. So, in our previous class, we have discussed about the continuity problem, and we'll discuss about that deleted portion also. In chapter number 7, right? So, in chapter 7, so look at that max deleted portion. Chapter number 7. Exercise 7.7, 7.8. These two exercise and example problems all are deleted in our syllabus, from our syllabus. Okay, that's chapter number 7.7, 7.8. Exercise 7.7, 7.8. Totally two exercises, and with that example problem, the corresponding example problems also deleted. That section totally deleted. Totally 11 exercises are there. In that 11, two exercises deleted. Okay, in chapter number 8, exercise 8.2 is deleted. Exercise 8.2, total that exercise and example problems, totally it is deleted. Okay, in chapter number 9, first volume we have discussed in yesterday. This is the second volume, deleted portion. Chapter number 9, exercise 9.3, totally that 9.3 exercise deleted. Okay, chapter number 10. In chapter number 9, 9.3 totally deleted, and in 9.6, one section only deleted. In 9.6, we have two type of equations. In 9.6, we have two type of equations we are going to discuss: dy by dx plus px py equal to q. Okay, and another one is dx by dy plus px equal to q. Okay, so this portion deleted. This is not in our syllabus. Only this in 9.6, part of the questions. Those questions representing that dx by dy plus px equal to q. That type of questions deleted, eliminated in our syllabus in 9.6. Okay, 9.6 full exercise not deleted. Please try to understand, full exercise not deleted. Only part of the question in 9.6 that is deleted. Those question it is in the form of dx by dy plus px equal to q, that is deleted. Okay. And chapter number 10. So it is exercise 10.5. But in your book, it is 10.4 only is there. 10.5 it is given in the last page of your book. Additional exercise. This is the additional exercise. This is also already it is in our syllabus, but now it is deleted. Now this portion is deleted. Page number 616. You please go through the book, NCERT book, page number 616, last page of your second volume. This additional exercise 10.5 given. Okay, so this 10.5 exercise, scalar triple products, eliminated, deleted. Okay, and chapter number 11. In chapter number 11, there is no particular section, particular exercise deleted. Only the angle problems. Look at that, the angle. Angle between two lines, angle between line and a plane, angle between two planes, all these are deleted. Please try to understand angle between two lines, angle between line and a plane, angle between two planes. That means that angle problem totally deleted. In every section, we have to discuss in lines, we have to discuss angle between two lines. In line and plane, we have to discuss angle between line and plane. In intersection of planes, we have to discuss angle between the planes. Okay, so this angle problem totally deleted from our 11th chapter. Okay. And chapter number 12, that exercise 12.2 totally deleted. That means formation of LPP. We have to formulate the LPP. LPP means linear programming problem. That linear programming problem, this is the linear programming problem. Is that equal to some 2x plus 5 subject to some condition x plus y is less than or equal to 1. This type of problem. This is the LPP problem. Solve LPP problem, that is in our syllabus. But some information given, theoretical word problem is given. Okay, so we have to convert that word problem to mathematical problem. That conversion is not there. Eliminating that conversion, 12.2. Okay, and in 13th chapter, in 13.4 exercise, there are three important points they are given. One is random variable and mean of the random variable and variance of the random variable. But this mean and variance of the random variable totally eliminated. Mean and variance of the random variable totally eliminated. 13.5 binomial theorem totally eliminated. 13.5 exercise, 13.4 some basic questions based on random variable they may be asked. Based on the random variable, the question may be asked, but the mean of the random variable, variance of the random variable, that two are eliminated. Okay, so these are the deleted portions. So these portions I have already sent to you, and you have a PDF also. You please go through the PDF. Okay. Right. So today we'll discuss about some more problem in that differentiation. After that, we'll go for the differentiation. Continuity. After that, we'll go for the continuity differentiation. Look at that. The problem, I think the question number 30 we have already discussed. Right? Look at the question number 31. My 31, question number 31 is show that the function defined by, show that f of x is equal to cos of x square is a continuous function. F of x is equal to cos of x square is a continuous function. So we know that cos x is continuous. Okay. We know that x square is continuous. What is x square? X square is a polynomial function. What is cos x? Trigonometry function. So all the trigonometry functions are continuous in their domain. Okay. So therefore cos x is continuous. X square is continuous. But take the composition of these two functions. What happened? So and take g of x is equal to cos x. H of x is equal to x square. Okay, so therefore my g composition h of x. What is g composition h of x? That is g of h of x. Okay, what is my h of x? My h of x is nothing but x square. Okay, what is my g of x square? Cos of x square. Please try to understand. Yeah, I will explain. Nagaraj, Nagaraj, I will explain. So look at that. I know that cos x is continuous. I know that x square is continuous. My x square is nothing but polynomial function. My cos x is the trigonometric function. These two are continuous. Okay, but the question is f of cos of x square is continuous. Okay, so this is nothing but your cos of x square is nothing but composition of these two functions, cos x and x square. So look at that. I am taking the cos x. G of x is cos x. My h of x is x square. Find G composition h of x. So G of h of x. My h of x is x square. G of x is G of x is cos x. But G of x square is cos of x square. This cos of x square is nothing but f of x. So look at that. From these two, I can easily find out G composition h is equal to f. Okay, now look at this result. If f and g are continuous, then my f composition g composition f is also continuous. If f and g are continuous, that means two functions are continuous, then its composition is also continuous. Okay, so therefore, here this is one function continuous, this is another function continuous, composition of this is continuous, that means this is continuous, that means this is G composition of H is continuous. G composition of H is nothing but F. Are you okay? You please try to understand. Use this result. This is result. When I'm using this result, I will get it as composition of two continuous function is continuous. That means this is continuous. Since this G composition F is continuous, this is nothing but F. Therefore, my F is continuous. What is F? F is nothing but cos of x square. So therefore, this function is continuous. Are you okay? So look at that. So my with this implies my G composition H is continuous, which implies my G composition F is nothing but it is my F that is continuous. Okay, my F of x is nothing but cos of x square. This is continuous. Are you okay? Are you clear? So to prove this is nothing but please look at that, and the cos of x square is a composition of two functions cos x and x square. Okay, so therefore that's why I'm finding, first of all I'm defining two functions g and h and taking composition and proving my G composition f is nothing but f. So once I prove that this composition is continuous, therefore this is nothing but f, therefore my f is continuous. I can easily prove it. That's why I'm finding that G composition h. Okay. So look at that. The 31st problem, 32nd. Show that f of x is equal to modulus of cos x is continuous. How to prove this is continuous? What is the meaning of continuous? Continuous means continuous at all the points. Continuous at a particular point means we have to find out the left hand limit, right hand limit, value of the function, all the three are equal means continuous at a particular point. At one point it is continuous. Okay. Similarly, you have to find out the continuity for every point. If the function is continuity at every point in the domain, then the function is simply said that it is continuous. So here we have to prove that f of x equal to modulus of x is continuous. Continuous means continuous at all the points. Okay, how to prove that it is continuous? I know that modulus x is continuous. I know that cos x is continuous. But I'm going to combine these two. I know modulus x is continuous. Okay, what is modulus x? My modulus x is nothing but this is the graph of my modulus x. This is continuous. See the graph? From the graph itself, we can conclude that modulus of x is continuous. Y is equal to modulus of x. What is my cos x? My cos x is coming like that. Okay, see the graph of cos x, that is also continuous. Okay, so this is y is equal to cos x. See the graph, from the graph itself, we can conclude that it is continuous. The graph is continuously we are drawing. This is continuous, this is continuous. But here the question is modulus of cos x. Then how to prove that this is continuous? Any idea? Any idea how to prove that this modulus of cos x is continuous? Use the previous one. Composition of two function is continuous. So I'm going to take it as my g of x is modulus x, my h of x is cos x. This is continuous. Please note that your g of x is continuous because modulus x is continuous. That is, we have already proved mathematically from the graph itself, we can understand it is continuous. And my h of x is also continuous. H of x means cos x. From the graph itself, we can find out it is continuous. And the previous class, we have proved about that sin x is continuous. In the same way, you have to prove that cos x is also continuous. Okay, right. So then, since these two are continuous, my g composition f of x is also continuous. Composition, just now I have told, composition of two continuous function is continuous. Right, now composition of g composition of h, not f. Right, now come to that, what is g composition h of x? Find out g of h of x. Okay, what is my h of x? My h of x is cos x. What is my g of h of x? Modulus of cos x. Okay, g of x is, h of x is cos x, g of x is modulus of x. Here cos x is there, therefore modulus of cos x. This is nothing but my f of x. Okay, so this is nothing but my f of x. So now g composition h of x is equal to f of x. Now I have already proved that g composition h is continuous. This is continuous. This is nothing but this. Therefore, my conclusion is f of x is continuous. What is f of x? This is my f of x. This is continuous. Are you okay? Please take that. Okay, come to the next problem. 34, question number 34. Find all the points of discontinuity. Find all the points of discontinuity of f defined by f of x equal to modulus of x minus modulus of x plus 1. Find all the points of discontinuity of f defined by f of x is equal to modulus of x minus modulus of x plus 1. How to prove that? Find all the points of discontinuity of f defined by f of x equal to modulus of x minus modulus of x plus 1. So I have already told that f and g are, if f comma g are continuous, then first one, f plus g is continuous, f plus g is also continuous. Okay, f minus g is also continuous, and f into g, this is f minus g, f into g is also continuous, and fourth one, f by g is also continuous provided g not equal to 0. Okay, sum of two continuous function is continuous, difference of two continuous function is continuous, product of two continuous function is continuous, division of two continuous function is continuous. Use this logic. Use this logic. In previous problem, I have used that composition of two functions. Here, the plus is there. Therefore, use this logic and prove that it is continuous or discontinuous. Is discontinuous means at which point this is discontinuous. You prove that. Any idea? Please try to complete the problem. Any idea? Yeah. Yes. Modulus x is continuous. Correct. Nagarjuna, you are correct. Modulus x is continuous. So, my g of x is modulus x. Let my h of x is modulus of x plus 1. Okay. And this is continuous. Modulus x is continuous. This is also modulus x only. Your modulus of x plus 1, both are modulus function only. Okay. So, therefore, since the modulus function is continuous, so my g and h are continuous. If these two are continuous, this composition is also continuous. Okay. So what is my G composition F? Find out my G composition H. G composition H of x is equal to, I'm sorry, this is not a composition, addition. Because G plus H of x or G minus H of x. G minus H is also continuous. Okay. So here not composition rule, apply that difference of two composition function is continuous. Okay, so therefore this is my g of x, this is my h of x, this is continuous, difference between these two, that is another function that is also continuous. This difference is nothing but my f of x. This g minus h, this is g, this is h, g minus h is nothing but my f. Therefore, my f of x is continuous. Okay. Right. Okay, we have almost covered all the problems in our exercise 5.1. Now we will move to that 5.2 exercise, that means differentiation. Okay, what is the differentiation of x power n, e power x, cos x, sin x, tan x, 1 by x, constant. Okay, what is the definition of x? What is the definition of x square? Any idea for the differentiation of x power n? You have already studied. What is the definition of x power n? Any idea? Differentiation of x power n. Yes. What is the differentiation? N into x power n minus 1. Correct. So n into simple formula. N into x power n minus 1. What is the differentiation of e power x? E power x only. What is the differentiation of cos x? Minus sin x. What is the definition of sin x? That is cos x. What is the definition of tan x? That is secant square x. What is the definition of 1 by x? 1 by x differentiation. Constant differentiation, 0. X differentiation, 1. X square differentiation, 2x. What is 1 by x? My 1 by x is nothing but x power minus 1. Okay, what is the differentiation of x power minus 1? So therefore, minus 1 x power minus 2. This is nothing but minus 1 divided by x square. This is 1 by x differentiation, minus 1 divided by x square. Okay, right. So these are the derivative formula that are you have already studied in physics also, 11th in maths also. Okay, so many times we are applying differentiation in physics. Okay, right. Suppose two functions are like that. Y is equal to some results. These are the results. Y is equal to some u plus v. U is also function of x. V is also function of x. Then how to differentiate that? This is dy by dx is dy dx of u plus v. U plus v or u minus v. Okay. What is the differentiation? The differentiation is you have to differentiate separately du by dx plus or minus dv by dx. Okay, du by dx plus or minus dv by dx, correct. Okay, my second result is, suppose my y is equal to u into v, multiplication. What is the differentiation? Here addition or subtraction means no problem. There are two terms. So differentiate separately each term. Okay, and add or subtract according to the symbol is given. But here this is only one term, but two functions it is in multiplication, u and v. Okay, u into v. So then how to differentiate? What is the formula? Yeah. So my suggestion is you first of all differentiate this. That means u dash, keep it v as it is. Look at that, your dy by dx or y dash or y1, all are same notation only. All are different derivatives. Okay, suppose du by dx. My du by dx or u dash or u1, all are giving the same meaning. Here u dash means derivative, differentiation. First differentiate this, u dash v plus v dash u. You please try to follow this formula, u dash v plus v dash u. Why, sir? Because what about my quotient formula? My y is equal to u by v. What is the formula? So this is dy by dx is equal to, okay, this same u dash v, the same u dash v minus u v dash, okay, whole divided by v square. So therefore, this is v square. Okay, u dash v minus uv dash divided by v square. Please try to understand. Here also u dash v plus v dash u, because if you change these two, no problem. Sir, I am changing this term here and this term here, sir. I am writing like that, sir. uv dash plus u dash v. Yeah, this is correct. This is correct. But if you are writing like here, uv dash minus u dash v by v square, this is wrong. This is entirely wrong. Okay. So therefore, you please keep it this u dash v plus v dash u, the same thing here with minus u dash v minus uv dash or v dash u by additionally 1 v square. Okay. So therefore, try to understand that quotient formula. This is called as product rule. This is product rule. This is quotient rule. This one is quotient rule. You please note it here. There is no place. This is quotient rule. Okay. Yes. Come to the next. Next, some results. The fourth result. These are also results. Okay. The fourth one is every differentiable function is continuous. Every differentiable function is continuous. A function is differentiable, definitely it is continuous. Look at that. Cos x differentiable, that is minus sin x. This cos x is continuous. Okay, sin x differentiation is cos x. That differentiable, differentiation exists. We can find the differentiation. So therefore, that is continuous. Okay. So therefore, every differentiable function is continuous. Example cos x. You take that example also. Differentiable and it is continuous. Right? Now come to that fifth one. So all the continuous functions, need not be differentiable. All the continuous functions need not be differentiable. Why, sir? What is the example? The example for the function is continuous but not differentiable is my modulus of x. Okay, so therefore this is modulus of x. This is continuous. See the graph. We can easily find out this is continuous. But this function is not differentiable. What is the differentiation of modulus x? We have a differentiation for x, we have differentiation formula for x square, we have differentiation formula for x power 1 by 2, we have differentiation formula for root x. Okay, modulus x, we don't have a differentiation formula. Okay, so modulus of x, we don't have a differentiation formula. Why, sir? At this point, x is equal to 0. Okay, you have to find out the derivative. At this point, x is equal to 0, the function is continuous. But if you find the derivative limit, derivative means derivative limit. Okay. So left derivative and right derivative both are not equal. So therefore derivative does not exist. Okay. So derivative does not exist means it is not differentiable, right? So I don't want to go for that proof left hand limit, right hand limit. You just take the result. My f of x is continuous, modulus x is continuous, but not differentiable. Why? My left hand limit, right hand limit are different, not differentiable. Okay, so this is the example for the function is continuous but not differentiable. Okay, and look at that some examples for this one. UV product rule. When we have to apply product rule, suppose y is equal to x square plus cos x. What is the differentiation? My differentiation is very simple. X square is 2x. Cos x is minus sin x. Okay, so therefore this can be written as 2x minus sin x. Right. Suppose I'm giving that y is equal to x square into cos x. What happened? X square into cos x. Into means product. We got some product rule. Product of two functions. What is the product rule? So this is x square plus cos x. What is the differentiation for this is 2x plus cos x differentiation is minus sin x. This is 2x minus sin x. Suppose x square into cos x. Then what happened? My f of x is x square into cos x. This is my y. What is my dy by dx? Take it this as u, this as v. Apply product rule. What is my product rule? U dash v plus u v dash. You always keep this is first term u dash v. Okay, and u v dash or v dash u. So u dash v. What is my u dash u differentiation? X square. So differentiation is 2x cos x plus x square into cos x differentiation is minus sin x. So therefore this is 2x cos x minus x square sin x. Yeah, very good. Now come to that. My y is equal to x square by cos x. What happened? My x square by cos x. Apply that u by v formula. What is u by v formula? Which is our u, which is our v? This is my u, this is my v. So therefore, my dy by dx is nothing but, so u dash v, this is u dash v cos x minus v dash u. What is my v dash? V is cos x, differentiation of cos x is minus sin x, and u is x square, whole divided by v square, cos square x. So therefore this is 2x cos x, this is minus into minus plus x square sin x, whole divided by cos square x. So after that it is not possible to simplify. Okay, so this is the example for these are the examples for that. quotient rule, product rule, everything, right? So the next one is derivative of or differentiation of composite function. What is that, sir? Composite function means. So suppose I'm taking as, let my y is equal to tan of 2x. This is composition of two functions. One function is 2x, another function is tan x. So if you take it as g is equal to tan x, okay, h is equal to 2x, then what is my g composition h of x? My g composition h of x is g of h of x. My h of x is 2x, tan of 2x. Okay, so therefore this is composition of two functions. How to differentiate composition of two functions? We have to take composition as a, we have to take g, h, everything as a. So it is not like that. We have to take a composition, that is correct. But for the shortcut for this differentiation is, that means within one step how to write the differentiation for this type of functions. For this type of functions, so if your y is equal to tan 2x, how to differentiate? So the differentiation with respect to x is, your y differentiation is, okay, dy dx of y, that is dy by dx. Tan x differentiation is, just now we have discussed, secant square x. You consider this is one function x. Okay, so keep it that x as it is, secant square 2x, and the differentiation of dy by dx of this 2x. Okay, so after differentiating this tan 2x, after differentiating this tan 2x, okay, you differentiate this 2x again. Yes, correct. Not cos 2x into 2 sin 2x. You have to apply for tan 2x means you have to apply for sin 2x by cos 2x. You have to apply for u by v formula also. Okay, but this is a shortcut. This is the simplest way to find the derivative. Tan x differentiation is secant square x. You consider this as x. So therefore here I am getting 2x as it is. And now differentiate this function again, d by dx of this 2x. 2x differentiation is 2 alone. So therefore my differentiation is, my dy by dx is, okay, secant square 2x into 2. X differentiation is 1. So therefore this is 2 secant square 2x. Okay. Now come to that, the next problem. This is called as composition of differentiation of composite function. Composition of two function. The second problem is, let y is equal to cos of x square. What is the differentiation? My differentiation is dy by dx is equal to, cos differentiation is minus sine of x square, minus sine of x square. Again differentiate this x square. Okay, what is the answer? Minus sine of x square into dy by dx of this x square is 2x. So therefore minus 2x into sine of x square. Are you okay? What about this? Y is equal to sine of cos x square. How to differentiate this? Sine of cos x square. How to differentiate this? Composition function. No need to take the composition. You just take it as what is the sine differentiation? Cos. You consider this is entirely x. Sine x. What I'm telling you, please try to understand. You consider this is entirely some x. Sine x. What is sine x differentiation? Cos x. So therefore, my cos of x. X is cos of x square. Now differentiate this totally this x. dy dx of this cos of x square. Okay, please try to understand. Okay, so therefore, this is composition function. Your sin x means simply it is cos x, sir. Why, sir? If you take y is equal to sin x, what is the differentiation? My sin x is, what is the answer? Cos x. So you are simply writing this, not differentiating this. Here only you are differentiating this, but here you are not differentiating. So if you differentiate this, what happens? What is the differentiation of x? It will become 1. So therefore, usually that 1 we are not writing. In place of this, other than x is there. If x alone is there, no problem, the differentiation is 1. Any other function, x square or whatever it is, okay, you have to differentiate this function again. Okay, so therefore, here also I am differentiating, the differentiation is 1. So therefore, usually we are not writing that 1. But here it is not x, cos of x square, differentiate this cos of x square. So therefore, this is cos of cos x square. What is the differentiation of cos of x square? Minus sine of x square. Okay, again differentiate that x square because here you consider this as x. Cos x differentiation is minus sine x. And now differentiate this x. X means that is x square. D by dx of x square. So therefore, this differentiation is 2x. Here minus is there. So therefore, minus 2x. This is sine of x square. Okay, this is cos of cos x square. You please try to understand minus 2x. This is 2x. Here minus is there, minus 2x. Sine of x square, cos of cos x square. Okay, please try to understand. Are you clear? Shall we go to the next slide? Yeah, very good. The next one is that y is equal to sine of x square plus y. What is the differentiation? Find the derivative of this. Y is equal to sine of x square plus 5. Y is equal to cos of sine x. Find the dy by dx for all these problems, 4 problems. Try. Correct. First one is correct. Nagar Ushni, first one is correct. Second one. Deepika, your answer also correct, previous one. Which one you are asking, Deepika? Cos of Deepika, what is your doubt? Cos into x square as x square. Third sum. Look at that in third problem. This is cos of cos x square. No. Oh, you are asking that. Look at that. You are asking this cos of cos x square can be written as x. No, because in trigonometry function, cos inverse of cos x, only x, or cos of cos inverse of x is only x. Okay, here no inverse. Sir, can I write cos square, sir? Here also cos, here also cos. Can I write cos square x, sir? That is also not correct. This is also not correct. Okay, cos square is also not correct. You have to write as it is, Deepika, cos of cos x square alone. You have to write this. It is not possible to simplify. Okay. Right. Any other doubt? Seventh one, 1 by root 2x sine root 2x. Correct. Biology, seventh one is correct. What about the other problem? What about the fourth one, fifth one, sixth one? Let's look at that. What about this dy by dx? Cos of x square plus 5. Sine differentiation is cos. You can consider this as x and write it x. And now differentiate this x. This is 2x. 5 differentiation is constant 0. So therefore 2x cos of x square plus 5. Here look at that. My dy by dx is cos of sin x. Cos of sin x is minus sine of sin x. Okay, into differentiation of this sin x, that is cos x. So therefore the answer is minus sine of sin x into cos x. Okay. What about this dy by dx? Sine of ax plus b. This is cos of ax plus b into, in this ax plus b differentiation is a only, because x differentiation 1, b differentiation is 0. Okay, so therefore a cos ax plus b. So some students are multiplying this a here. It is not possible. So multiplying a is not possible, not correct. So don't multiply. Here dy by dx is cos root x minus sine root x. And again differentiation of this root x. What is differentiation of root x? Can idea what is the definition of root x? Yeah, 1 by 2 root x, correct. So root x definition is 1 by 2 root x. So therefore minus sine root x divided by 2 root x. Okay, so therefore this is the differentiation for the last problem. Okay, right. So today onwards we are giving some 5 to 10 homework problems every day. You will get it from that learnity, that means from our seeker's office. You may get the questions, homework questions for all subjects, not only maths. And you please try to complete that homework problems and submit your homework problems. Okay, if you have any doubt in that homework problems, you please send a message. We will discuss in our class. Okay, so please regularly complete your homework problems, do your homework problems, complete your homework problems and send that. Okay, that is very important, right? So tomorrow we will discuss about that another section, what the inverse differentiation of the inverse function. Okay, that we'll discuss. Okay, thank you all, thank you so much. If you have any doubt, you please tell me. If you want slides, this is our slides. Okay, thank you all, thank you so much. We'll meet in the next class.